All right, gang, Mr. Spencer here. What I want to do in this video is go through how to look at something and calculate all the forces that are acting on it. So far, we've been talking about how to identify all the forces that are acting on it. Now we're going to take it to the next level. So remember when we did this, the little Vietnamese SWAT team? Okay, what we're going to be able to do is look at that, use a little bit of data, and be able to extrapolate that to figure out what's going on with the other ones. But we'll get back to that here later. Now, just a review, all right? When we're talking about constant velocity, meaning things are going at either staying still or going in a straight line at a constant speed, there's no speeding up, slowing down, or changing direction, that means that there are balanced forces that are acting on that object, okay? So, just like this right here, whatever this thing is right here is it's not accelerating, meaning there is an equal amount of force going this way as there is going the opposite way. We're going to use that to be able to figure this out. So let's think about this. All right, look at these examples right here. So let's assume that there's a net force of 0, meaning that there's balanced forces going on. If we have this information, how would we figure out what A is? Well, if it's balanced and I know that I have 50 newtons that are moving this way, okay, that means that I'm going to need to have 50 newtons pulling the other way. So A would be 50 newtons. Same thing with B. If this is balanced, I know that if I have 200 newtons pulling down, then B is going to also be 200 newtons. Same thing over here. If 200 newtons are going down, in order for this to be balanced, 200 newtons need to be pulling up. All right, same concept in this one. All right, if I have 300 newtons pulling up, that means there's going to need to be 300 newtons pulling down. If there's 80 newtons pulling to the left, then I'm going to need 80 newtons pulling to the right. Now, here's the one little, what's the word I'm looking for? I forget. We'll figure this out. If I have a mass of 5 kilograms, what's the force that's pulling down? Well, that's a force due to gravity. How do we calculate the force due to gravity? Well, that's going to be mass times the acceleration due to gravity. And if we're on Earth, that's going to be 9.8. So 5 kilograms is not the force, all right? That's important to understand. 5 kilograms is not the force. That's the mass. The force, or the force due to gravity, is going to be 5 kilograms times 9.8 meters per second squared. And that would give us 49 newtons. So we would have 49 newtons pulling down, and that would mean we'd have 49 newtons pushing up. All right. So do you see how that works there? We want to be able to use a little bit of information to figure out the rest. All right. Now, here's what happens. Sometimes we get several of these that are going in the same direction. So if I have a mass of 5 kilograms, that means the force due to gravity, I'm going to take mass times the acceleration due to gravity, so that's going to be 5 kilograms times 9.8 meters per second squared, which gives me 49 newtons. I would know that these two together would add up to 49 newtons. All right, that's going to be important, because what we're going to try to do here is figure out how these different how to figure out what these different forces are. So for example, if I have a rightward force, okay, applied force, that's pulling a 6 kilogram object, causing it to move across a rough surface, so there's going to be friction, and it has 15 newtons of that friction, how would we figure that out? Well, if I have my force due to gravity is going to be 6 kilograms, is going to be 6 kilograms times 9.8 meters per second squared. I'm trying to find my calculator here. So if I have 6 times 9.8, that's going to give me 58.8 newtons of force due to gravity. So that means my normal force is going to be the same as that. And if I have 15 newtons of friction, that means I'm going to need to be pulling with 15 newtons. So once again, you're using a little bit of information to figure out what the other missing parts are. Now, let's say I have same idea, but this is with 19.6 newtons. Okay, and we have a mass of 10 kilograms. Well, how are we going to do that? It's going to be the same as before. Because it's balanced, if I'm pulling left with 19.6 newtons, I'm going to be also pulling to the left, or pulling to the right with 19.6 newtons. If I have a mass of 10 kilograms, I have a force of gravity of 10 kilograms times 9.8 meters per second squared, which gives me 98 newtons. So that means our normal force is going to be 98 newtons. All right, let's skip this one. All right. Okay, so what's going to happen here is we're going to start getting into a little bit of using trig to find the horizontal and vertical components of these forces that are at an angle. So just as a review, all right, with trig, we're using these relationships between sides of a right triangle. All right, and it is all based off of this thing called theta. Okay, theta represents the angle that we are using. All right, so hypotenuse is the longest one, so that's our h right there. Adjacent means that it is the side next to theta, so this is going to be our adjacent, and opposite is the side that's opposite theta, so that's going to be over on this side. So if I wanted to do this, if I wanted to be able to find this opposite side and this adjacent side, I'm going to need to use those trig functions. Well, I know that theta is 20 degrees, and I know that the hypotenuse is 450 degrees. So what I'm going to need to do here is recognize when there is I'm going to need to recognize which trig function I'm going to need to use. Well, if I'm using this side, or I'm trying to find this side, it is the opposite of theta. So SOHCAHTOA. So means sine of theta equals opposite over hypotenuse. Well, that's what I would use for this one. I know that the sine of 20 degrees is going to equal the opposite, which is what I'm looking for here, divided by the hypotenuse, which is 450 newtons. So I would set that up, and I would use algebra to figure that out. Now down here, this is the adjacent side, so SOHCAHTOA. So it's not so, all right, it's ka, all right, which is cosine of theta equals adjacent divided by hypotenuse. So I know that the cosine of 20 degrees is equal to adjacent, which is this side, divided by hypotenuse, which is 450 newtons. So once again, I'd put sine, it's early. Okay, cosine of 20 degrees equals this adjacent side divided by 450, and solve for that. All right, so let's use that. All right, let's say that we have a box that's being dragged by a rope at a constant speed across the floor. What we want to do is draw the force diagrams that's identifying all of the horizontal and vertical forces. All right, so what forces do we have acting on this? Well, first of all, we have this applied force. All right, it's that 50 newtons that's being pulled at an angle of 22 degrees. All right, but we also have the force due to gravity, or its weight, that's pushing down or pulling down towards the center of the earth. We have the support force of the ground, the normal force that's pushing up, and then we have that friction force that's acting to the left, all right, opposite the direction of motion. Well, how are we going to figure that out? Well, that's exactly what we've got going on right here. So what we need to think about is this rope. It's at an angle, but what we know is that if we look at the components, because it's at an angle, there's a little bit in the horizontal direction and a little bit in the vertical direction. So we're going to need to break up this force of tension at an angle into its horizontal and vertical components. So this is what we're doing. Once again, I take this force of tension that's at the angle, I know that it's part this, which is the force of tension in the x, and it's part this, which is force of tension in the y. So I go and I take this and I break it up into its components. So now I have two of these forces that are acting up. I have the force of tension in the x, that's going to the right, the force due to gravity, which is going down, and the force of friction, which is acting to the left. So I can start figuring this out. So if I want to find the force, I know that the force of friction is going to equal the force of tension, all right? Because those are the only horizontal forces. I know that the force of tension in the y, all right, is going to, I'm going to use some trig there. So when I set this up, I know that this, if this is my theta, right here, the 22 degrees, then this is my adjacent side, and that means I'm going to use cosine. And if this is theta, this is my opposite side, so I'm going to use sine. All right. So when I calculate that out, I get the force of tension in the x, all right here is 46.4 newtons, and the force of tension in the y, right here, as 18.7 newtons. And now this is where I start trying to figure things out. So if I know this, that I have 18.7 newtons of tension in the y and 46.4 newtons of tension in the x, how do I figure out these other ones first? So let's take the low-hanging fruit first. All right, let's go and let's say, take a look at this. I know I can figure out the force due to gravity. I know that this is 8 kilograms. All right, so if I know that this is 8 kilograms, I can find the force due to gravity by taking 8 kilograms times 9.8 meters per second. All right, so that's going to be 78.4 newtons. When I'm trying to find friction, I know that friction is going to equal the force of tension in the x. So if this is 46.4 newtons, then this is also going to be 46.4 newtons. I would say the most difficult one is trying to figure out this stuff. Well, what you have to understand is that the forces going down equal the forces going up. So I can rewrite that as saying the force of gravity is going to be equal to the normal force plus the force of tension in the y. Hopefully that makes sense, okay? These two added together equals this one. So now I just start plugging things in. Well, I know that the force due to gravity is 78.4 newtons. I know that the force due to tension in the y is going to be 18.7 newtons. And now I just need to solve for that normal force. All right. Well, if I do that, if I do the algebra, I end up with a normal force of 59.7 newtons. The idea is that you are using this to try to take the information that you know and then try to figure out the other things. It's kind of a puzzle, but I know you can do it. Let me know if you have any questions.